8.7 is the lesson over solving quadratic equations using the quadratic formula. As we have previously mentioned in this box, to solve a quadratic equation means to find the x-intercept. This is the point where the y value is 0. But sometimes we can't find the solution from the graph, which we talked about when we did factoring, and the expression can't be factored. So that means we need to have another method for being able to solve these equations. And this is a lot of steps and it seems really complicated at first, but using the quadratic formula is actually everybody's favorite way to solve a quadratic. So if you use the quadratic formula, you can literally solve any quadratic equation. So you do have to do some setup, and it is important to get this setup correct before you start trying to put things in the formula. So the first thing is you have to make sure that the equation equals 0. And we'll do some on the next page where they do not equal 0, and we'll talk about how important it is that you make them equal 0. So this is the first step. Make sure it equals 0. The second step is to identify your A, B, and C. Now, A, B, and C are going to change after you get it equal to 0. So that's why you have to get it equal to 0 first and then identify A, B, and C. Also remember, these are only numbers. No variables are part of the formula. So you are not going to put in x or x squared. You're only putting in the coefficients. The third part, after you know what A, B, and C are, is you are going to do the substitution into the actual formula. So that requires you to make sure that you know what the formula is, and you can use this paper. It's always, going to be right here. And make sure that you put B in for B, A in for A, and C in for C. Now, we use B first, which sometimes people get them backwards and put in A first, and it's really important that you don't do that. So make sure that you are putting the right number in for the right letter in the formula. Step 4 is to simplify the parts. So we have 3 main parts. We have negative B, we have 2A, and then we have the discriminant. So we have used this before, and this is part of the quadratic formula as well. So the b squared minus 4ac part that is right here in the formula has to be simplified separately before you try to take the square root. All right, and then the last step is to simplify the square root and solve the problem. So after you simplify the square root, you're going to know what kind of situation you have. And the 3 situations are here on this first page. And so after you know whether you need to simplify the square root or if it's a perfect square and you can actually solve it, we'll decide on how you finish the problem. So we're going to do one of each of these right now. So we have square root is a perfect square is one option. Square root is not simplified, and we have to simplify it. And the square root is already simplified either because it is a prime number or it does not have a perfect square inside of it. There's actually a 4th one that we will not learn about in Algebra 1, and that is where we have a negative square root, and therefore our answer is going to include imaginary numbers. But we're going to leave that for Algebra 2. All right, so the first one here is the perfect square. So it already equals 0, so that means step 1 is done. Step 2 is to identify your A, your B, and your C. Make sure that you are applying any minuses as negatives. So notice I have minus 12 in my problem, so that makes C equal negative 12. All right, after you know those, and this is one that you wouldn't want to graph or factor because it has this 3. So that's going to make, for the graph to look weird. It's also going to make it harder to factor. So this is a perfect example of why we have the quadratic formula. Then we're going to substitute these into our formula. So the formula starts negative b plus or minus the square root. And then inside the square root, you're going to have b squared minus 4 times a times c. All right, and this is the discriminant part like we've already talked about, and you have to use those parentheses. Okay, so don't be lazy about that. Just put them in there and use them. And then on the bottom, we have 2 times a. Okay, the next step is to simplify the parts. So we've got -5, so we're just going to keep that inside the square root, which I made that way too big. Okay, we're going to put this part into our calculator. So I'm going to have 5 squared, make sure the square is outside the parentheses, minus 4 times 3 times -12, and hit equals. And so that's 169. And then on the bottom, 2 times 3 is 6. Now, whenever you get this and you want to see if it is a perfect square, sometimes you're going to know just by looking that it's a perfect square. Sometimes you have to actually do the square root and see. And this one is a perfect square. So we're going to have -5 plus or minus 13 equals 6. Once you take the square root, you no longer need the square root symbol. So the square root of 169 is 13. Notice there is no square root anymore. So once you use it, you lose it. All right, and then the last step is we're going to separate this into a plus problem and a minus problem. And we can put both of those into our calculator as fractions and let the calculator do the work. So we've got -5 plus 13 over 6. So that means one of our answers is x equals 4/3. And then we're going to do that again. -5 minus 13 over 6. And so our other answer is -3. So this one's going to cross 2 times, once at 4/3 and once at -3. And that's why you may have noticed that it had this plus minus symbol in the formula. That's because we have to add whatever the square root is and we have to subtract it. All right, and so then our final answer can go in the solution set, -3 4/3, like so. So that would be our answer. Okay, so that one, we probably could have factored it, but because a is 3, it would have taken us a little bit more time. And so using the quadratic formula let us do that pretty quickly. All right, the next one is a not simplified square root, which means we're going to have to simplify it. We're going to start the same, finding a, b, and c, because step 1 is already done. It already equals 0. So a is 1, b is -2, c is -12. All right, and then we're going to just put that in the formula. Now remember, the formula starts with -b. So that means that you have negative of whatever b is. And in this case, that's -2. So the negative in front of the parentheses comes from the formula. The negative in the parentheses comes from the fact that b has a negative number. So make sure that you do not lose one of your negatives. Then we're going to have -2 squared. Make sure you use your parentheses. -4 times 1 times -12. And then on the bottom, we're just going to have 2 times 1. Okay, so now step 4 is to simplify these parts. So -2 is +2. And then we can put the discriminant portion into our calculator. So that's 52. And then on the bottom, 2 times 1 is 2. Now, if we try to do the square root of 52, we're going to see that's going to give us a decimal. And remember, algebra, we don't like decimals. So we are not going to put that down as our answer. We're going to simplify this like we did the other day using the sled method. Now, if you can see the perfect square in there, feel free to go ahead and do that. But I'm going to show the sled method for those that might need it. So 52 divided by 2 is 26. 26 divided by 2 is 13. 13 will only divide by itself. So this is our answer. So we do have a pair of 2's. So that means we're going to have a 2 on the outside and 13 back in the square root. Okay, so we have 2 plus or minus 2 square root of 13 over 2 for our simplified square root. Remember that this pair of 2's gives us this outside 2, and this 13, because it doesn't have a mate, has to go back in the radical symbol. Now, because we have a 2 in front of the plus minus and a 2 in front of the square root, then we can simplify that with the 2 on the bottom. Think about it like we can simplify this fraction and this fraction. So 2 divided by 2 is 1. So you're going to have x equals 1 plus or minus, and then 2 divided by 2 is 1 square root of 13. And then 1 times the square root of 13 is just the square root of 13. So our final answer here is going to be 1 plus or minus the square root of 13. Now, if we graph that, this is what the graph is going to look like. So the 1 minus the square root of 13 is here at about negative 2.57. And 1 plus square root of 13 is over here at about 4.57. So those, you definitely wouldn't find those on your table because they're not on whole numbers. You definitely wouldn't be able to factor this because it ends up with a square root in the answer. And so this one is one that you have to use a different method. And this works perfectly with the quadratic formula. Okay, the last one we're going to do is the square root is already simplified. So what that means is we're not going to be able to do this part and make a simplified square root. We're going to just have to keep what we get, and you'll see why in just a minute. So just like before, we're going to start with A, B, and C. It already equals 0, so I'm ready to go straight to this part of the problem. So A here is 1. B is negative 9, C is 15. Then I'm going to substitute them into my formula. So I'm going to have negative, negative 9, because negative in the formula and negative with the B, plus or minus, negative 9 squared minus 4 times 1 times 15. And then on the bottom is 2 times 1. And a lot of times it is 2 times 1. Okay, now we're ready to simplify the parts. So negative 9 is just 9. And then our discriminant will simplify. So we're going to do negative 9 squared minus 4 times 1 times 15. And make sure when you type that into your calculator that you look back at your work and make sure you're typing in what you're supposed to. So that's square root of 21. And then on the bottom, we're going to have 2 times 1, which is 2. Now, if I try to do the sled method on 21, 21 will not divide by 2, but it will divide by 3, and that gives us 7. Well, 7 will only divide by 7, and then we have 1. So we get no pairs. So if there are no pairs, then the answer that we get is the answer that we have. And we can't do anything to simplify it. So this answer would be 9 plus or minus the square root of 21 over 2. Now this definitely is not one that you could find the answer by graphing because of that square root, nor could you find the answer by factoring, again, because of the square root. So you have to use this method of quadratic formula in order to get that answer. On the next page, we're going to do some that do not equal 0, and so we have to rearrange them before we can do any work.